our video on chemical bonding. So in this discussion series, we will see how metals and nonmetals combine via two types of bonding and learn how to depict atoms and ions with Lewis symbols. So bonding is the joining of two atoms in a stable arrangement. Remember in General Chemistry 1, it was discussed that elements will gain, lose, or share electrons to reach the electron configuration of the noble gas closest to them in the periodic table. So this is in accordance with the octet rule that for an element to become stable, it must have 8 electrons in its outermost shell. So based on the rules, or based on this rule, elements can either transfer or share electrons with other elements, and it results into two different kinds of bonding. So these two types of bonding would be the ionic bonds, which result from the transfer of electrons from one element to another, and covalent bonds, which results from the sharing of electrons between two atoms. For the first type of bond, ionic bonds form between a metal on the left side of the periodic table and a nonmetal on the right side of the periodic table. Remember that in our previous discussions, we write the chemical formula of ionic compounds and we consider their charges and crisscross them to become subscripts. So those are examples of ionic compounds. Now, covalent bonds, on the other hand, are formed when two nonmetals combine or when a metalloid bonds with a nonmetal. So in here, a molecule is formed which is a discrete group of atoms that share electrons. So here's an example of a covalent bonding between hydrogen atoms. So you have here two atoms of hydrogen forming a hydrogen molecule after sharing electrons. Here is an image of the periodic table to remind everyone of the location of the elements within the periodic table. So the metals here, the metalloids in the staircase-like area in the periodic table, and then we also have the nonmetals on the rightmost side of the table. While in here, in this table, it presents the magnitude of some atomic properties across a period. So for example, in terms of atomic size, it decreases across a period. So it decreases from left to right. Meaning, if we talk about metal atoms, they have a larger atomic size compared to non-metal atoms. So same goes for the different trends of these properties. We have the ionization energy and electron affinity. So here are the trends that they are lower in the left side of the periodic table and then higher on the right side of the periodic table. And then since we talk about the valence electrons, we have here a method that is used to show the valence electron of interacting atoms. So we call this the Lewis electron dot structure. The dots around the element symbol will represent the valence electron. So to draw the Lewis symbol for any main group element, note that the A group member, which gives the number of valence electrons, and place one dot at a time on each of the four sides of the element symbols. So keep adding the dots, pairing them until all of them are used up. So example here, we have here nitrogen. So nitrogen, or N, is in group 5A. Therefore, it has 5 valence electrons. So you can draw one dot per side and then pair them up until they are all used up. So note that the specific placement of dots is not important. As seen in the example, the Lewis symbol of nitrogen can be written in different ways. And then, for a metal, the total number of dots in the Lewis symbol is the number of electrons the atom loses to form a cation. Remember our discussion in General Chemistry 1 that metals tend to lose electrons. So aside from counting the valence electron, it should also reflect how many electrons will the atom lose to form the cation. And then for a nonmetal, the number of unpaired dots will be equal to the atom that will be gained to form an anion, or the number it shares to form covalent bonds. So as I have said earlier, the octet rule will be followed here, which states that when atoms bond, they lose, gain, or share electrons to attain a filled outer level of 8 electrons. So here are a few examples of the Lewis symbols of the elements from the second and third periods. So we use the Lewis electron dot symbol for main group atoms. And that's it for our first video on the chemical bonding and the Lewis electron dot symbols. Thank you for listening.